going to discuss that how to code a CNN model. So here are the steps to train a CNN model. So we will discuss every point one by one. So the first thing or the first step we have to do is find data. So in our case, we are making F1 image classification model. So our data is this. We are using this data, and we can see that this data has 10 classes, and every class has some images stored. We have 10 folders of every car brand in F1, and every directory have some files, which is in our case images, and we have to code this in our Google Colab. So this is pre-written code. Let me zoom in. So the first thing we have to do is import our data in our Colab notebook. So this is the code. I will provide code link in description, so there is nothing to worry. I have already downloaded this data. This is our data. So the second step is to clean the data. It means if we have any corrupted image in our data, we have to remove that. So this code is for that. We have to remove. This will take a main image directory as input and remove any corrupted image in the directory. So yeah, we are done with that. And our third step is to import necessary libraries which we are going to use for training our model, for creating our model and writing our code. So these are the important libraries. These are the libraries that we are going to use. So we have to import these libraries. Image data generator, this is for data augmentation. VGG16, we are going to use this as our base model. We are training this model on transfer learning. If you don't know what is transfer learning or fine tuning, you can take a look at the videos of Campus X, Convolutional Neural Network. That's a playlist of 100 days of deep learning on the channel of Campus X, and he has explained that thing very well. So you can take a look at that video, then come to visit this for coding purpose. So these are the libraries: sequential, flatten, dense, dropout, Adam as our optimizer, and reduce on plateau as callbacks. So these are the libraries which we have to import for coding our CNN model. So our fourth step is data augmentation. So this is not a necessary step. This we usually use this step for augmenting images. It means if we do not have enough images or enough data, so we can generate new images from previous data. So as we have less images in our data, as you can see, we have only 123 images in this directory, and we have 364 images in this directory. So our data is biased. So we will use data augmentation, and here is the code for data augmentation. So this will take main directory as input. Main directory means where all images are stored or classes are stored, and this is the code which define that how our new generated image will look. We can rescale image, rotate image, and shift the width of image, height of image, share the image, zoom image, and it will create new images for us. And the fifth step actually, is splitting our data in testing and training part. So this code is for that purpose. In these lines, we are splitting our data in testing and training directories. And we have to just pass our main directory here and here to split the data. And this target size, this is very important. We have to define this target size. This is the input size for our convolutional neural network. Our model will expect 224 by 224 images every time. So this will be same for whole code. And here is the batch size. We will pass 32 images every in batch, and this is subset. This is our training data, and this is our validation data or testing data. So sixth step is to define our CNN model. Now this is most important step. So here we are defining our CNN model. So we are using VGG16 as our base model, and this method is called fine tuning, or using pre-trained CNN models to train our new model. So we are using VGG16 here. Let's take a look at VGG16, that how VGG16 architecture looks like. So as we can see, here's a convolution layer, then we have max pooling, then we have convolution, then we have max pooling, then we have convolution, and so on. So it's expecting 224 by 224 images, and 224 by 224, and one this plus ReLU activation, and so on. So we are using this as our base model, but we are using from here to here only. We are using only these layers of VGG16 in our model. So this is our base model. This is our actually convolution layers. These are the convolution layers that we are using, and we are freezing last four layers of VGG16. So we are freezing these layers. We are freezing these layers and defining these layers by ourselves. So we have base model, means our VGG16, and then we have flatten layer, which is basically this layer. We are flattening the output that are coming from base model, and then we are passing those output in dense layer of 512 neurons. And then we are adding dropout for overfitting, to prevent overfitting actually. And then we are using one more dense layer, one more dropout, and one more dense layer. This dense layer is for our um, mm, for prediction actually. And we I think this is wrong, so we have to pass 10 here because we have 10 directories in this data. So we have to pass 10 here. This is most important part of the code, that in softmax it will predict. What softmax do, it predicts the probability, the highest probability of class. Means it will only give one output. It will give 10 output, but one of them is most probable output, which is our main output. So then we have to compile our code as a seventh step. So we are compiling our code here. We are using optimizer, Adam as optimizer, and loss function is categorical cross entropy because this is a classification problem, and matrix accuracy. This is for giving accuracy. And this function reduce on plateau function. This is very important function. It just reduce the learning rate if it sees our model is overfitting or doing some unusual things. So it will reduce the learning rate. And now we are fitting our model, or passing our training data, steps per epoch, and number of epochs. We are using 20 epochs, but we will not train because the data is big and we have less computation power actually. So you can train it up to 100 or 200 if you have enough RAM, GPU, and a good system. So this is our training code, and we will run this code and see if it works. So we have 4054 images belonging to 8 class. This is actually the previous code that I've ran in this directory. You have to run this code, this which I've showed you now. You have to run this code, and you have to pass 10 here for this data, and then you have to train this model. So as we can see, after 20 epoch, we got 93% accuracy, 94% accuracy, and 80% validation accuracy. And now our model is trained and ready to use. So we will see in next video that to how to use our model for prediction, for prediction, um, and how to make app, how to make app or website, how to make web app um, from CNN model. So this is our topic for next video. So stay tuned for making app of this model. And yeah, thank you.